we need to simplify the following. So first, what we'll do, we'll combine cosine theta plus cosine phi. We'll use the trigonometric formula whenever we have cosine of theta added to cosine of phi. So that's given by 2 times cosine of theta plus phi over 2 multiplied to cosine of theta minus phi divided by 2. Then we have sine theta added to sine phi. So this is given by 2 times sine of theta plus phi over 2 times cosine of theta minus phi divided by 2. Therefore, cosine of theta plus cosine of phi added to iota times sine theta plus sine phi. So this will be equals to 2 times cosine of theta plus phi over 2 times cosine of theta minus phi over 2. Added to iota times, we have 2 times sine of theta plus phi over 2 times cosine of theta minus phi over 2. Now here we see that in the two terms, cosine of theta minus phi over 2, that's common. So we can take, also 2 is a common factor, so we can take out 2 times cosine of theta minus phi. This will be common, and this will get multiplied to cosine of theta plus phi over 2 plus iota times sine of theta plus phi over 2. Now, in the next step, what we'll do, we'll raise both sides to the power of n. So the entire expression will be raised to the power of n, so that we have 2 raised to the power of n times cosine raised to the power of n of theta minus phi over 2 times this entire expression will be raised to the power of n. Now here we can apply the De Moivre's theorem, which simply states that cosine of theta plus iota times sine theta whole raised to the power of n, that's given by cosine of n theta plus iota times sine n theta. So that means we can rewrite our expression as 2 raised to the power of n times cosine raised to the power of n of theta minus phi over 2 times this expression, when we apply the De Moivre's theorem, will become cosine of n theta plus n phi divided by 2 plus iota times sine of n theta plus n phi over 2. So this is the expression, which is the first term. Now when we do the second term, we'll get everything the same, except for the fact that in place of this particular positive sign, we are going to get a negative sign. So let's write it down as well. We have cosine of theta plus cosine of phi. This is minus iota times sine of theta plus sine of phi whole raised to the power of n. So this will be also equals to 2 raised to the power of n times cosine raised to the power of n of theta minus phi over 2 multiplied to cosine of n theta plus n phi over 2 minus, so this is the difference, we'll have a negative sign here, times iota times sine of n theta plus n phi over 2. So our goal will be, so if we label this as equation number 1 and this as equation number 2, so we'll add 1 and 2. So this is going to give us 2 raised to the power of n times cosine of n of theta minus phi over 2. So this is common to both the two, 1 and 2. So this will get multiplied to. So here we add the iota, the imaginary part will get cancelled out because they're additive inverse of each other. So we're left with 2 times the real part, which is cosine of n theta plus n phi over 2. So we can combine this 2 with the 2 raised to the power of n to get 2 raised to the power of n plus 1. And therefore our final expression is going to be, so we have cosine of theta plus cosine of phi plus iota times sine theta plus sine phi whole raised to the power of n. So this is added to cosine of theta plus cosine of phi minus iota times sine theta plus sine phi, everything raised to the power of n. So when we add them, so we are going to get this expression. So here we will have 2 raised to the power of n plus 1 times cosine raised to the power of n of theta minus phi over 2 multiplied to cosine of n theta plus n phi divided by 2. So this is going to be the simplified expression.